Figure 11.28 MouseTrackerFrame.java and Figure 11.29 MouseTracker.java. In this application, we're going to demonstrate some mouse tracking capabilities, and for the first time, we're going to show you a class that implements more than one interface. In particular, we're going to implement the mouse listener and mouse motion listener interfaces to be able to track various different types of mouse events. Now, to show you the basic functionality, first I'm going to go ahead and run this application. And when it comes up, we're going to be able to demonstrate 7 different mouse events to you. And I'm actually just going to go ahead and stretch this window a little bit here. So first of all, at the moment we see in this J label at the bottom of the window that the mouse is outside the J panel. The white area in this window is a J panel object on which I have registered to track various mouse events. Now, as I move the mouse into the J panel, you can see that as I'm moving the mouse, I'm getting dynamically changing coordinates, and those coordinates are with respect to the very upper left corner of that particular panel. So now I've got the mouse positioned exactly at 0, 0, and I can go all the way down and move around. As soon as I go outside, it recognizes that I'm outside and stops tracking the mouse, but when I come back in, it recognizes the movement again. So the entry and exit events are what are causing the change from white to green. White for when I exit and green when I enter. And as I move, I'm seeing the tracking of the mouse. Now, if I press the mouse down and start moving, so first you saw that I had a pressed event, now I have a dragged event, and when I let go I get a when I let go I get a released event. So press, move, and release gives you a pressed event, a dragged event, or a series of dragged events, and a released event wherever you let go of the mouse. So again, pressed shows you when you press the mouse that a mouse button was pressed. Moving the mouse shows the dragging event, and by the way, as I drag, watch what happens if I go outside of the bounds of the window. If I go outside to the right, it keeps tracking. We also get the exited event, which is why the background color of the window changed. And as I keep moving the mouse around, you notice it keeps tracking me, also getting to negative coordinate values because it's tracking me with respect to the upper left corner of this J panel. So as I go up to the left, I get negative coordinates. As I go down to the right, I continue to grow the coordinates in each case. So the coordinate values start at 0, 0, and for the x coordinates get greater as I go to the right, and for the y coordinates get greater as I move down. So we've showed you mouse enter and mouse exit. We've shown you mouse move, mouse press, mouse drag, and mouse released. The only other thing we haven't shown you is what's called a mouse click event, which occurs when you press the mouse and let go without moving the mouse in between. And that doesn't matter how long you press for. As soon as you let go, you get a clicked event. So that's kind of a little bit strange because, as you know, when you have to do things like double or triple click on things, you usually have to do that very rapidly, but you can test for that as well in Java, because it turns out that the mouse event objects can give you back a so-called click count, which is based on the threshold for clicking on your particular system. So if you don't click fast enough and you keep getting the value of the click count, it will always be 1. But as you click very rapidly, then the click count will increase until you finally get to a point where you don't click within the threshold amount of time. And we'll show you that in the next example. So we've got 7 different mouse events that we're tracking here: entering and exiting the window, moving, dragging, pressing, releasing, and clicking are the 7 different events. And what we wanted to do is show you how you can deal with all of those events in one example. So let me go ahead and close that window, and let's take a look at our MouseTrackerFrame class, which extends JFrame. As far as the features in this example, we're now going to talk about a border layout. We have the use of the java.awt.color class to change the color of the background. The border layout is the default layout for a JFrame, and basically the way a border layout works is it enables you to place objects around the outside of your window at the top, the bottom, the left, and the right, and then it also has a center region as well. In addition, we're using both the mouse listener and mouse motion listener interfaces, which we'll talk about more in a moment, and all of the different mouse event handling methods receive a mouse event object as their argument. Finally, the last new piece is a JPanel, which is going to be the GUI component that was in the main part of the window, which we registered our mouse events for. JPanels are just generic containers that may contain other GUI components, or that you could customize to create your own new GUI components, or even could be used as dedicated drawing areas if you were creating a drawing application. In our MouseTrackerFrame class that extends JFrame, we've declared a JPanel called MousePanel and a JLabel which we called StatusBar, and we're going to attach that to the bottom of our window. And then our constructor is going to set up the GUI and register the event listeners. So at line 21, we use the super keyword syntax to invoke the superclass constructor and specify our string for the title bar of the window. We then create a blank JPanel object called MousePanel, and we set its background color initially to white. And then we add the JPanel to our window, but using a new version of the add method that takes as its first argument a component to display, in this case the JPanel, and as its second argument the region into which we'd like to display the GUI component. And just going back to the running version of this application, as far as the regions go, the JLabel at the bottom here is displayed in what we call the south region. There's also a corresponding north region, and then there is a west region and an east region. However, we're not using the north, the west, or the east. So what happens for the center region, which we are using with this JPanel, is it expands to fill all remaining space in the window. And that's why this panel of color is occupying the rest of the window at any given time. Right, so that's why we use borderlayout.center for the JPanel. At line 27, we create our JLabel, which initially displays mouse outside JPanel, and we attach that status bar JLabel to the south region of a border layout. And the south region always expands all the way across the window, and it will only be as tall as the GUI component you place in it. Finally, in the constructor, we create an object of our own nested class called MouseHandler, which we'll look at in just a moment. And then we use that as the event listener object for the mouse panel's add mouse listener method, and also for the add mouse motion listener method. In each case, the add mouse listener and add mouse motion listener methods require an object that implements the mouse listener and mouse motion listener interfaces respectively. So let's take a look at the object, or the class rather, called MouseHandler, and make sure that our handler object really does meet those requirements. You'll notice here at lines 36 and 37 that we have a new class called MouseHandler. It's a private nested class used only in this application, and it says it implements mouse listener, comma, mouse motion listener. Well, if it says it implements both of those listener interfaces, then a mouse handler is a mouse listener and a mouse handler is a mouse motion listener, and thus it meets the requirements of being able to be passed to either the add mouse listener or the add mouse motion listener methods. By the way, these methods are from class component originally, so you can actually track mouse events on any type of component in all of the Java graphical user interface capabilities, whether they be from the old java.awt packages or from the javax.swing packages. Now, in our mouse handler class, because we've said implements mouse listener and implements mouse motion listener, we have a number of different methods we have to define. To figure out which methods we have to define, let's go take a look at the online documentation for those interfaces. And I'm going to go all the way back to the java.awt.event package, which is where they're defined. And you can see there's quite a number of listener interfaces listed here. Let's look at mouse listener first. And when I go to the method listing for mouse listener, you'll see that there are 5 methods that we must implement if we say we implement the mouse listener interface. Remember, when you implement an interface, you are saying that you're signing a contract with the compiler that you will in fact define every single one of these methods. And if you go click on any one of the method links here, you'll see the full first line of the method definition without the public keyword, because remember, everything in an interface is considered to be public by definition. And for each of these methods, you can see that they have a method name that is based on the specific type of mouse event they want to be handling. In this case, mouse clicked. They all return void, and they all receive a mouse event parameter. So we have mouse clicked, mouse pressed, mouse released, mouse entered, and mouse exited. Notice that the movement events, mouse moved and mouse dragged, are not listed here. They are part of the other interface. So let's take a look at mouse motion listener. And for mouse motion listener, you'll see that we have two additional methods, mouse dragged and mouse moved. And if you look down here, you can see what the first line of mouse dragged and the first line of mouse moved need to look like. So because our class says it implements both of these interfaces, we have to define all 7 mouse event handling methods that are declared in those two interfaces. So first we begin with the mouse listener event handlers here, and we have mouse clicked, mouse pressed, mouse released, mouse entered, and mouse exited, the 5 different methods that are specified in that interface. And let's take a look at each one. So when the user clicks the mouse at a given location, we're going to tell our JLabel to set its text to the following string of information that is created by the string class's static format method. We're going to print that we clicked at a particular location, and we're going to show you the X and the Y coordinate where we clicked. And built into the mouse event object that we receive automatically as an argument is a getX and a getY method that allow you to obtain the X and Y coordinates where the mouse was when that event occurred. Similarly, for mouse pressed, when we get that event, we're going to print out or display rather a string in our status bar JLabel indicating that we pressed at a particular location. And again, we will call getX and getY on the event object to obtain the coordinates. And we do the same thing for mouse released here as well. For mouse entered, we actually do two things. We do tell the JLabel to display the text mouse entered and show you where we were at that time, but it turns out it's really hard to move the mouse slowly enough to see that event, which is why I've set up the mouse panel to set its background color to green also when the mouse enters the area of the JPanel inside the window. As for mouse exited, when we do exit, we're no longer inside the window, so we simply say that the mouse is outside the JPanel at that point, and we also set the background color of the JPanel back to white, so we get some visual interactivity as the mouse moves in and out of the window. And then at the very bottom of this nested class, we also define the mouse motion listener event handlers. For mouse dragged, we can see that we're doing the same thing as most of the other event handlers. We display the string dragged at followed by the coordinates of the event. And then for mouse moved, again, we do the same thing, displaying the coordinates where we are moving the mouse at a given time. So we've got this nested class that says it implements these two listener interfaces, and because it implements both of them, an object of this class can be used to register to handle either mouse listener or mouse motion listener events, and that gives us a total of 7 different mouse events we can process in our example. Now, as you look at this, you might say, well, what happens if I don't want all of those different events? What if I only care about mouse clicked and mouse moved, for example? Well, it turns out that there is a concept called an adapter class that can be used in that case. You can extend the adapter class, which provides for you an implementation of every method of the corresponding interfaces, and then you simply override the particular method or methods that you're interested in. And that's the last thing that we're going to show you in this chapter in the next example.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.